Okay, we have here today another integral from the Chennai Math Institute 2025 Finals number 2. We have the integral from 0 to pi squared over 4, 1 over 1 plus sine square root of x plus cosine square root of x dx. Okay, for a starting point, we definitely have an obvious u substitution. We can clear up the square root of x, and then I think we can also simplify our bounds at the same time. So what I want to do is u equal the square root of x. And let's solve for x, so we'll have x equals u squared dx equals 2u du. And then we'll substitute the square root of pi squared over 4. When you plug it in there, it's just going to become pi over 2. Square root of 0 is 0. Then we'll plug in for dx. This is going to become a 2u here. And then everything else, we're just going to be plugging in u. So we'll have sine u plus cosine u. And for the next step on this, I think what I want to do is King's principle on it. What we're going to need is this f of a plus b minus u value, where a plus b is the sum of the bounds, so just pi over 2. So we're plugging in pi over 2 minus u into this. So when we do it, this is what's going to happen using the formula. The bounds are going to stay the same. The key is right here, we're plugging in pi over 2 minus u. But now in each of these, we have the complementary angle formula. So sine pi over 2 minus u is going to become cosine. Cosine pi over 2 minus u is going to become sine. So what's going to happen is it's just going to go exactly back to the way it was. I'm going to change the order and put it back like that. So we have sine u plus cosine u. And then just distributing in the 2, we're going to end up with pi minus 2u in the numerator. But then from here, what we can do is we can put a label on it, call each of these integrals I, and then we can just add them together. So what we're going to end up with here is going to be 2i, and we can pull these integrals together. It's going to work nicely because we've got the same denominator. So when we do that, we're going 0 to pi over 2, just copy down the denominator. But when we add them together, we got 2u minus 2u. What's going to happen is that's going to cancel there, and we're just left with a pi right here. But because pi is a constant, we'll bring it out front of the integral. We'll leave this as just a 1. We'll have a pi right here. Divide off the 2, and we have pi over 2 in front. That cancels, and we've isolated our I. And now we still have an integral to do, but this one, I've done this one before. So let me clean up the board, and we'll just finish it off with this integral. Okay, so the way I want to approach it is with a Weierstrass substitution. We have all of our formulas over here to the right. I've derived these in previous videos, so I'll provide a link in the description if you want to check that out. But here we're just going to use this complicated substitution with all the formulas. So first, we'll have the constant out front. We'll update our bounds with this. So we'll plug in for u. So when pi over 2 is u, here we're going to have tan pi over 4, but tan of pi over 4 is a 1. And then we plug in a 0, tan at 0 is just 0. For our du value, we'll use this one. So we'll have 2 dt. Then I'm going to bring it out here because we're going to use this to cancel with. So we're going to have 1 plus t squared that I'll bring all the way out here. For the 1, I'm actually going to try to set up the cancellation and write it as 1 plus t squared over 1 plus t squared. I'm just doing that because we have this 1 plus t squared everywhere. Then for sine, we'll use this one. And then for cosine, I'll try to squeeze this in right here. And then all that's left is to simplify, but we're going to be able to cancel. See, now when we multiply this in to the parentheses, this is going to cancel here, here, and here. The 2's are going to cancel here. And so what we have is going to be a lot easier. We're going from 0 to 1. And then we just need to add all this up. But again, look, the t squares are going to cancel because that's got a negative. So all we're left with here is going to be just 1 plus 1 is 2 plus 2t. And then I can factor a 2 out on this thing, right? So we're just left with, so all we have left here is going to be just 1 plus t. But that's going to be pretty easy. We can just integrate. We have pi over 2, natural log, absolute value 1 plus t, even though we don't need absolute value because it's always positive. And we just need to evaluate from 0 to 1. Plug in, the first value is going to be pi over 2, natural log of 2 plugging in there. Plug in a 0, we're going to have, this is just going to become ln1. but ln1 is 0. So putting it together for my final solution, we just get pi over 2 ln2, and that's it. Okay, there you go. Good problem from CMI 2025. Thanks everyone for watching. Have a good day.